Alright, today's 7th grade lesson is on volume, and we're going to start with basic volume today. And what we're going to do is eventually move into some more complex type figures with volume, but we're going to start with rectangular prisms, which is the easiest geometric shape to work with volume. But remember when we were talking about surface area, we were taking a 3D object such as the water bottle. And with surface area, excuse me, we were talking about the outside surface. So we'd find the area of the surface on the outside. Now we're talking volume. In volume it talks about how much water can we fill inside the water bottle, or what can fit inside of a shape is what we're talking about. So that's the difference between surface area and volume. And we already talked about that with that intro, but it describes a space occupied by a shape. Okay? And to introduce how we find that for a rectangular prism, we're basically trying to count how many cubes there are inside a rectangular prism. How many blocks that are the same size are inside this shape. And what we can do is count all of them. Let's take a look at the bottom row, or the bottom part of the figure, and it'll make it a little more clear. See how this works here. Something like that. And I'll try to draw as best I can. Let's do one, two, three. Not the best, but it should work. Alright. Something like that anyway. This would be more so like this. Okay, that looks a little better anyway. Not perfect, but you'll get what I'm doing. Okay. Bring those down. And then we've got 3 here. And those go across like so. Alright. I've done better, but it works. Alright, but anyway, you get the main idea. What we would want to do is count how many blocks there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 blocks, and how many levels of blocks do we have? We have 3. 1, 2, 3. So 3 times 12 gets us 36 blocks. So our volume would be 36 blocks, or 36 cubes. But we do have a shortcut to that, and we just go, we have 3 here. 1, 2, 3, 4. And then 1, 2, 3. We can do 3 times 4, which is 12, times 3 gets us to 36. And that is the formula to find the volume of a rectangular prism. Length times width times height. And that's what we're going to use to help us save time. And we will see that coming up soon here. Alright, this is just mainly to show, just like what we just did, counting each cube. It says volumes are measured by using cubes of a standard size. So a cube that has edges of 1 centimeter has a volume of 1 cubic centimeter, which we abbreviate like this. Centimeters to the 3rd power. Alright? So area, we talked about square units, now we're talking about cubic units for volume. So similarly, if we had 1 meter for a cube, it'd be 1 cubic meters. 1 foot would be 1 foot cubed, or 1 cubic foot, sorry. So just to know that we're using cubic units. So to use the formula here, it says find the number of 1 centimeter cubes that can be placed inside a rectangular box with the dimensions shown. This is just asking us to find the volume. And we know now that volume is length times width times height. Our length is 5, our width is 4, and our height is 3. So we do this. 5 times 4 is 20. 20 times 3 is 60, and we are in centimeters. cubed. Alright? Now that's a very basic volume problem. We're obviously going to make that a little bit more difficult, except for the next one. It's pretty easy. If we were given a cube, how would we figure out the volume? Here you could do 4 times 4 times 4, and you would get your answer. Should be 64 cubic inches, I believe. So that would be that one, but I'm more so talking about something more difficult, such as this. We have a couple ways to do this. Excuse me for a second. We can either figure out the total volume that this would be if this piece was here, and then subtract out this piece, or we can treat this figure like two figures, split it apart, and then add two volumes together. And that's the way that I'm going to do it right now. So we need to look at this piece right here. Something like that, okay? So we have that top part and we have a bottom part, two prisms. So let's pull those apart here. Alright, and let's just first focus on the red one. We got to figure out the dimensions here. So what would this length be? Well, this is 4 centimeters, which means this is 4 centimeters, which means this part is also 4 centimeters long. Okay? What about this piece? That correlates to this piece right here, which is 4 centimeters. So we have a 4. Now figuring out the height of that piece is a little bit more challenging, because that is this piece right here. And we got to look at what we know. Well, we know the whole length here is 8. So we have 8 centimeters there. And we also know this distance right here, or this height, which is 4, because this is 4. Okay? So now we got to ask ourselves, 4 plus what gets us to 8? Well, 4 plus 4 gets us to 8. So that has to be the missing height, which is also 4. So we do have a cube on top there, and we have our dimensions that we need. We have a length, a width, and a height. So now let's look at the bottom piece. Something like this. Alright, so we've got that. Erase this. This height is 4, because that goes right over to there. And well, we already know this is 4, because that's given. Alright? And we also found out that that piece was 4, we just did that. Okay. And then we know that this is 4, because that is this piece. And we know that this is 8, so this has to be 8. Alright. So now to find the total volume, we find the total, or we find the volume for each, and then we add them together. Length times width times height, 4 times 4 times 4, which is 4 times 4 is 16, 16 times 4 is 64 centimeters cubed. So that's the volume of the top portion. Let's get the bottom portion. Volume equals length times width times height, which is 8 times 4 times 4, which is 8 times 4 is 32. 32 times 4 is 128 centimeters cubed. So now to figure out the total volume, we add those together. 64 plus 128, we should get our answer. Add. Oops, no, don't carry that. So it should be 192 centimeters cubed. 192 centimeters cubed. Alright, so that is basic volume for rectangular prisms. We're going to, like I said, eventually move into some more challenging types of volumes. But but that's all we were gonna do today.